Yeah, that is about the test points. It's two important test points. One is a pad and one is a component. Now we start with the probes. So on the right side here, you see a circuit. This is similar to a probe. So you have always a resistance and a capacitance. And you will probe the test point. For example, we have here one and here's a ground. So we want to measure the clock signal. And we have an internal resistance or circuit resistance. So let's see the effect of the resistance. So at the beginning, we learned the voltage divider. So we have here also probe resistance, circuit resistance. And with this divider, we divided the clock signal. So you generate such a clock here, but we measure only this clock, so a lower supply here. So it means we have always a divider, and you can change the resistance to a higher resistance also. So we have 10 times probes, but we see it later. What is the problem of this? Now the effect of the capacitance. Of course, we have also capacitance, and the RC here is generating a pole. And this pole filter out the high frequency components of your clock. Therefore, we have such a clock here. And with a rise time about 2.2 times the circuit resistance and the probe capacitance. So these are two parasitics of the probe. So I'm 1 times the resistance and 1 times the capacitance. So there was a question. Question is, where is V out? Yeah, V out, I mean here. This is V out and here is VD. So we want to measure this point here. So normally at each oscilloscope you have a probe with 1 time and 10 times. It means that you can increase your impedance from 1 mega ohm to 10 mega ohms, and also the capacitance sometimes decrease. This depends on your probe, and the bandwidth increase. And the good thing you can see here is that with 10 times you have a higher voltage to measure. This for high voltage signals, very nice. But the resolution goes down. So if you want to measure very low resolution, you have to take the one-time probe. And the advantage of one-time probe is, you can see is one time is only resistance and the capacitance, that you filter out also one signal, you don't see the high frequency noise. And you have a lower resolution, what is very nice to see some changes. For example, temperature change and so on. And if you take the 10 times probes, so what you do is to put a resistance and capacitance parallel on the line, the probe line. It is very nice for high voltage measure because you divide the voltage here 10 times. So if you have 100 volts here, then you have here 10 volts. What you measure. This is from the circuit. And you have, of course, a wider bandwidth because of the capacitance here. So the wider bandwidth is very nice then for measure high frequency signals. And before you start to measure, I can recommend you to compensate your probe. Means maybe you saw it sometimes on the oscilloscope. Often under the display, you see something like this. You have ground and you have clock signal. So you put your probe here and compensate it. Because what you are doing here is to change this and this capacitance here. If your probe is uncompensated, then if you put your probe here, then you will see not a good red signal, you will see something like this. So you can also see here, this is undercompensated, this is overcompensated. And you can hear something, there's something what you can turn right or left side. And there you can change the resistance, sorry, the capacitance. And then you can put it like this one. So you have to change the capacitance like that, such that you have a very nice clock signal. And that means that your probe is then compensated. So you compensate the complete line of the probe. And then you can start to measure your PCB. And then you will also get very accurate signals of measurements. Now we come to the last part. This is a fiducial marker, or some markers. I think you often saw it in PCBs. This is here. And here, this is only a point with no connections. Also, sometimes you see it on the left side here or something like this. Often you put these markers, if you have a PCB, 3 times here, here, and here. And these markers are only for assembling. So if you have 1000 PCBs and you want to assemble it so that the producer will put with a machine the components on the PCB, then the machine have to figure out, okay, where to put the components. And these are the markers where the camera detects the markers, and then the machine knows, okay, where to put my components. Therefore, you need then such a marker here. So the markers are not connected to ground and also not connected to VDD. So it's only not connected device or not connected to component or pad. And you can try it. You can take your motherboard from your computer and then search someone. You often see such points. Yes, and this is, as I said, a very short presentation today, but I showed you already all important stuff for PCB design. So there is no more information for you. There are some small information, but it's not necessary for you. So you learned everything. You learned everything about traces, what is important, and component placement, and about power supply, also power traces and ground traces. And yes. No, I didn't forget some. Do you have some questions? Did you already try to produce a PCB?
Hello, Marco. Hello, Marco.
Yeah, hello.
Will you help me to find out is my spice model of 3.3 volt regulator? I'm not able to find the spice model. I'll send you
You mean this one?
number in chat box. Not this one. It's 1117 3.3.
So what do you... Yes, what about this? So this is the LDO regulator. And what is the question about this? Spice component is not able. Did you try to search it on analog.com? Of PDF. There should be a spice model. Boy, the spice on my computer. You have to go on the side here on the top. On the bottom, you see some examples for testing of this model. Do you have more questions? And at high power design, what do you mean with high power? Do you mean high currents or you mean more high voltages? Because these are two different design types.
High current would be good.
Sorry?
High current, I guess.
Okay. So I've researched something and maybe if you're interested, we can do a new session about it. But I will first try to search some documents about it. So I know I have some. I have to search it and then send it to you. Do you have a big or PCB manufacturer in Nepal? Okay, local levels. Okay, from China, yes. It's also very cheap in China. And maybe another question, when is the best time to travel to Nepal? September to November, okay. Good information, thank you. Sounds interesting. So maybe next time you have to try to do your first PCB and see where are you have problems, or figure out the problems. And then you can write me also, and maybe we can do 1 or 2 months again a session and talk about your problems, or you can show me your problems and so on if you are interested. Or if you have some topic where you want to learn a little bit more, for example, in high power design. Then also you can write me. So if you have then no more questions now, then we can also close the session. Of course, you can write me each time email. Power adapters. Oh, I have to write it down. What do you mean with electronic speed controls? You mean like control a motor? For example, brushless DC motor or DC motor? Okay, yeah, no, I know. I see. Okay, this is also a very interesting topic. Yes, we can do a session about this one. This is a very good session.